as I heard Carl just he arrived last Sunday.
Oh, no, Bangladesh.
Yeah.
Cambodia, sorry.
Cambodia.
Bangladesh.
Yeah.
Bangladesh, Cambodia is his market.
Yes.
Not easy. I cooperated with him for 2 projects in Bangladesh. Wow, customer is totally different. Not the same issue. Right? 没有那个是来的稍微。
Good morning.
Good morning.
First, thank you, Sarah, gave me this opportunity to share some drawing knowledge with you. So, my name is Moyo, and I'm the team leader of the BCHA drawing team.
Oh.
So, today's our topic is about drawing process technology. This is contents. So, it is including the BCHA drawing history, the drawing theory, computer drawing configurations, and drawing parameters. BCHA drawing technology comes from the company Eric Light. This company is located in the United States. These are some notable historical markers for this company. In 1940, the company founded as the American Digital Wires. And in 1953, it changed the name to Eric Light. And with the decades of development, a variety of the wires have been designed and sold. In 2008, Eric Light was acquired by the Biller Group. And in 2010, first here, BCHA built the first smart drive, the separate DAB. And since then, we have sold more than 500 drives over the world. The slide shows the function of different machines. The left is the processor equipment, the right is the primary function. We can connect them together. The drivers we can use to remove the moisture ovens. It can bring the chemical or physical change. And the roasters can bring the flavor change. Toaster can bring the color change. Expander can change the internal structure. The coolers can remove the heat. On the picture, you can see that the temperature of the ovens, roasters, and the toasters are high. And the airflow speed of the toasters, coolers are fast. And you can see that there is an overlap between these machines. So it means there are some similar functions of all these machines. This is some similar factors. First, they all remove moisture, and second, they all use airflow for heat and the mass transfer. Third, they are all energy intensive. Maybe need to use most energy consumption, and they are vertically negative in some stood. We usually say the drive is very important. So why do we drive? The primary objective of the drive is to improve the product shelf life. We know the shelf life is very important. If it is short, the product cannot maybe easy to damage. Right? The secondary objectives including first bring about the desired chemical change and change the ability and change the color. These are some other benefits, such as reduce water for material handling, and reduce the waste disposal cost, and reduce the shipping charges. The other important reason is profitability, because we know the final goal of the company is to make a profit. The moisture uniformity is very important. This is also a key point during the dryer commissioning. So why is it important? This is some matters. First, most products have a maximum moisture level. If the moisture is high, the shelf life will be decreased, and the bacteria can occur. This is not good for the product. And second, the product properties is also affected by the moisture uniformity, such as the taste, color, and crispness. The moisture uniformity can also affect the downstream processing, such as the coating, reactivity, and the absorption. On the other hand, we cannot do the overdrawing, because overdrawing means lost the production, lost the product weight, because most products are sorted by the weight. If overdrawing by 30% means 30% of the product goes out. Overdrawing also means the energy wasting. Some our customers may be focused on the energy consumption. So another point is drawing pushing is not at the end of the process. You can see below. You can see that this is the whole process line, including the extruder, dryer, cooler, coat, and packaging. There are three stages of the drawing. First, the energy to water in product to phase change. Second, water evaporates from the surface of the product, and the vapor is carried away by the air. Third, the moisture diffuses to the surface of the product to replace the evaporated water. In the step first, so it takes heat to evaporate the water, and in a dryer, the heat comes from the air. In step 2, you can imagine the air like a sponge, because if it has a better contact with the product and the air is drier, the vapor rate will be fast. Step 3. The water diffusion of the water to the surface of the product, and the diffusion is a function of the product composition, the size, and the moisture content. And every product has its own drying curve, so we can explain the curve. We usually divide the curve into 3 steps. The first step is the warm-up period. In this period, as we know, many products enter the dryer with low temperature. At the beginning, the dryer only warmed up the product and very little drying process. If the product enters the dryer at a very high temperature, maybe the warm-up period may be short and or non-existing. The second step is constant rate period. we see that the mass is decreased. Once the product is warmed up and a period of relatively rapid and constant drying takes place is the constant period. And during the period, water is available in the product surface and to be evaporated and carried away by the hot air. The drying rate can be determined by the airflow rate and the temperature. Because the heat and mass transfer are between the air and the product. So the step 3, it is a 40 rate period. So this is the critical moisture content. After the critical moisture content is reached, surface water is no longer available, and the drying rate will begin to drop. Here's some of the detailed explanation, maybe chemical explanation. During this period, drying rate may be defined by the product properties such as the size and the size, moisture content, and the next by the dry settings such as the airflow rate and then the temperature. So during the drying curve was about the drying rate. This is basically the picture shows the rate change. After the warm-up period, the drying rate is 0, and in constant rate period, the drying rate is half, and the falling rate period, the rate is drop. So this is about the product temperature change. You can see the red line. In the warm-up period, the product temperature is increased, and the constant period it is constant, and at the end it also increased again. Maybe this is easy to understand. This is the filters of product to affect drying. You can see that including size, surface area, solid type, and the product components, and the product density, and the moisture content in and out. Let's talk about the moisture content. There are two ways to measure product moisture content. One is the weight basis, and the other is dry weight basis. The weight basis definition uses water as a percentage of the total product weight. And the dry weight basis definition is water is a percentage of the solid weight. The right is the formula of these two ways. This is the water and the solids. This is the total mass. So this is total. This is the solid mass. So we usually use the weight basis to calculate the moisture in out. So let us use a simple example to calculate the moisture. So in here, the weight is 1200, and the solid is 900 and without is 1000. So the moisture in is right. Okay, and the water evaporated is 200, and the moisture out okay. Next, we change the moisture in to 27%. And in this case, the waste out and the moisture out are same. So, okay, so the water in, we can carry the W E. Right. So we can take the water evaporated is right, and we can compare these two values, right? We can get the increase is 30%. So we can get that only increase the 2% percentage of the moisture in the energy we need to be increased by 70%. Next example, we keep the moisture in 27 and the waste out is same. And the moisture out we can change to 5%. We can get the solids. Right, and we can with the in. And you can get the water evaporated is and we can compare with the beginning 200. There. So we increase the moisture in 2% and decrease the moisture out with 5%. In this case, the energy requirement will be increased by 51%. So sometimes some other customer focus on the moisture without, but for Europe we focus on the evaporate requirement. Okay. This is idiom, right?
Yes.
Okay. So next is about the command line configuration. In this topic, I will introduce the basic layer configuration and discuss the disadvantage and the advantage of different configurations and introduce some driver components. In Europe, there are many camera driver configurations. That they have some disadvantage and advantage. And during the driver design and during the driver design, we need to there are many parameters to be considered, such as product characteristics, the space available, and the access for cleaning, and some other important factors. These are the key peripherals of the driver. So first is the hub feature. It is widely used in the seat driver and the nut driver. The second is foot feet. It is widely used in our upper feet and the spare foot driver. The third and fourth are the bare feet. It's usually used in our industrial driver. This is the cut figure. It is usually used French fry drivers. Then the others are usually used vegetables driver. This is a single pass and a single stage. Single pass means it only has one pass per plate and one gear motor. One stage means it has one gear motor. This is a belt feed. This is feed end. This is heating zone, and this is the discharge end. This is the protector, press 9 in this driver. For this driver, we divide the heating zone into two heating zones. In each zone, we can control the airflow, temperature, and the humidity, and the exhaust value separately. And for the single pass, single stage dryer, we can also have a bait brush under the dryer in this location. The bait brush can clean the bait plate when the drying running. It is very convenient. They is useful for the maintenance of the dryer. So this is the advantage of this dryer. The structure is simple and it is very gentle for the product because there is no drop during the inside of the dryer. And it is easy access to cleaning and maintenance of the dryer because the door can open for. And it has a good control condition to the drying. And just I said before, the airflow rate and the temperature and the humidity can control individually. But it also has a disadvantage. No jaws to break up the columns and takes a lot of space, so it will be maybe very long and expensive. This dryer is usually use the synthetic rubber SAP, some cereal, and expand the snacks and the nut roasties. This is some picture of our customer site. This is the two-pass dryer. This is the product. This is the line inside the dryer. We also divide into two zones. This is just an example. We also have some bigger machine. Maybe have 3 50 zone and 4 60 zone. This is the three pass. They are similar to the pass. In this dryer, we have 3 bed plates, and each bed plate has its own motor. Here. In this dryer, we the difference between the class, we divided the into four units. We named it sequential. Maybe at the first the zone 1 with the drying air temperature can be set a little higher, in the zone 2, zone 3, zone 4, and can be set a little lower than in zone 1. Some of our foreign customers prefer this structure because maybe it is good for the product temperature of the dryer. So this is the advantage. We can run different bed depths and reduce the floor space and the noise control cost. These advantages cannot run different air temperature at the end of drawing compared to beginning. This is for to pass. And next accessible for clean the single pass. And the product may exist at the same end or at the event. Two into pass fit end and discharge end at the same side. And the three pass are different side. And go back to the three pass. This is the fit end in from the side, and this is the discharge. This is maybe this is maybe a disadvantage or advantage based on the certain event. This is the typical applications. Better food to the feeds, some cereals, half products, some vegetables. Okay, this is a single pass, multiple stage. In this picture, it has 2 stages. This is the first stage. In the second, this is the feed end, the product pouring the bed from here, and this is the zone. This is the transfer, the product from down here, from here to here, and then go to the second stage. And each stage has its own motor to control the bed speed, and you can also adjust the product depth. This structure is similar to the single pass, single stage. So the advantages and the disadvantages are same with the single pass. Okay. It take a lot of floor space and maybe very expensive. This structure usually used in coating the cereals and the French fries, the peanuts or grapes, and the vegetables and fruits. We have also more than 30. How to say? This structure are almost customers the dryer. We maybe each dryer, each project need 3 months to design the dryer. Take the solution, not a standard dryer. Okay. This is more to the components. This is the single pass dryer, and we can say that it only had only one cleaner. This is the conveyor belt, the cleaner, the heater source in this picture. The heater source is a steam coil. Now this is the recirculation fan. Then this is the exhaust fan. Make up a damper. This is the airflow inside the dryer. The recirculation fan pulls the air from the makeup damper and the air from air mix them together and blow it to throughout the place. This is to help us to understand clearer. So more important configuration inside the dryer is the bed plate. So we usually, this is our normal, but maybe in a situation maybe it maybe have some other names. This is the heat source burners. We also have another heat source steam coil. For some French dryers, we also use hot water coils. Because in the French dryer, the drying air temperature is not high, maybe 66. So for this dryer, we usually use hot water. The temperature of the hot water is about 85 degrees. This is about the outside drying components, such as the recirculation fans and the exhaust fan. This is the configuration inside the dryer. This dryer we call it a single cleaner in a single pass. Single pass means it only has one bed plate. Single cleaner means it only has one cleaner on one side of the dryer. Sometimes for this kind of the dryer, in order to provide the uniform airflow throughout the product, we usually set a plate installed in this position. There are many holes. On the plate, and the configuration are different. the goal of the plate is to make the airflow, to provide the uniform airflow throughout the plate, so that we can provide the moisture uniformity. So, this is the advantage is simple, compact, and good access from the more side. From this side, we can open the door and do cleaning and maintenance of the dryer. Disadvantage including the non-uniform and cannot change the airflow direction. And the heat source is close to the duct. Next is the single pass dual cleaner. So in this dryer, here is the burner. This is the recirculation fan. This is the mix plate. It is used to mix the. Here is the makeup air, and this is the fire to before the plate, maybe the air and the heated air are not mixed in. It is not useful. It is not good for the recirculation fan. So we need to mix them together and provide the heated temperature air. In the end, the recirculation fans can pour air into the heating zone. So this dryer can provide a uniform drawing, can be designed to allow airflow direction to change. How to change? You can see that here is a plate and here is a plate. In this picture, the air can through here bottom, and through the plate, the air direction is upflow. And if you change this plate from here to here, and this plate from here to here, the airflow can throughout like this, and the airflow direction can be down flow. On the other hand, the dryer has more complex structure, and the height of the dryer needs to be increased. And maybe the cost will be high. This is two pass dual cleaner, and it is widely used in our outfit and benefit dryer. And this dryer will also sort of move about 200 or 700 dryers we have sold. This is the airflow inside the dryer. Understand? Yes. Okay. This is also the in the detail. Okay. Next. We already provided the alternating airflow to the dryer, because if the airflow direction is all the same, you can say that the bottom or the top, the moisture can be dried fast. But if the direction is upflow, the bottom can be dried fast, but the top maybe the moisture may be a little high. So we usually provide the alternating airflow up down, up down, up down, like this. This is a typical two-pass airflow. This is the burner, and this is the makeup damper, and this is the recirculating fan. This is the mixed plate, and this is the fixed plate. This is the open area. We can adjust the location of this plate or this plate to adjust the airflow direction. This is same. We also had an exhaust damper, but in this picture it didn't show. This is a 3-pass. Noise. The structure is similar to the pass, just increase one plate. Here is the exhaust damper, and here is the mechanical damper. Okay. Next is about the dryer rating parameters. So, we usually said we need to achieve the uniform dry. So we need to consider from the following items, such as the uniform the intake product moisture from the extruder, and the uniform air temperature through the product, and the uniform the airflow, and the stable rotation time. And there is no jumps or clusters in the product. From the equipment side, the basic factors controlling equipment, including the volume of the airflow, velocity, and the temperature, and the humidity, and the direction, and the distribution. The radiation time and the bed depth are the key factors. Another factor is the product excitation. From the product side, the product size, shape, and solid type, product ingredients type, and the formulation, and the pre-coating, moisture content are the key points for controlling. So, next is about the performance and the efficiency. As we know, for the dryer energy consumption, there are many important factors such as dryer construction, and the air velocities, and the radiation time, the loading, and the air recirculations. So, during the dryer conditioning, these factors we need to consider all of them. During the dryer design, we need to calculate the heat power of the dryer. So heat power including the following items. First is the latent heat that is used to evaporate the water. So the second is the central heat. It's including the 4 items for the heat the product, to heat the water in the product, and to heat the exhaust air, and to heat the conveyor belt. Another is noticed by the dryer constructions and the radiation and the leakage. This is the energy proportion of the proportion of different each kind of the energy consumption. The evaporation is very high. It's about 60 to 70. The heating air is about 25 or 30. And the heating product is only about 3 to 5. And the heating water is about 1 or 2. The others are not this. So this is just a theory, but actually we need to say so for each if it is not a standard dryer, we need to do some calculation and to choose the suitable power and to choose the burners or steam coolers. We usually use the heat balance. This is provided by the air glide because they have more than 6 years experience. They have a special calculation theory to do this. So this is the topic for the dryer. Any questions?